Now, a step towards more real channel conditions. In designing RDT 2.0, we are going to assume that the underlying channel is unreliable. But what does unreliable mean? In this step, the underlying channel still delivers all the packets, so no packet loss. However, bits could be corrupted and therefore flipped. How do we recover from these errors? To answer this, let's think about conversation between humans. Assume you're talking on the phone with your friend Alice, and Alice tells something that you do not understand due to bad line quality. What would you do? You will say, "Pardon me?" or "Would you please repeat that?" And Alice repeats what she said, which you could hopefully hear the second time or ask for a repetition again. This process has two elements at the receiver and one at the sender: detection of error and feedback from you, the receiver, and repeat from Alice, the sender. We will employ a similar approach to solving the problem in RDT 2.0. In data transfer, a similar approach to what we described in human phone conversation example could be employed. For detecting error, mechanisms like checksum could be used. For feedback, we can use ACKs or NACKs. Using ACK or acknowledgement, receiver explicitly informs the sender about receiving correct expected packets. In NACK or negative acknowledgement, receiver explicitly tells the sender that the packet had errors. In events of error detection, a corrective action, which is repeating or retransmitting the packet, is performed by the sender. In computer networks, reliable data transfer protocols based on such retransmissions are referred to as ARQ, or Automatic Repeat Request Protocols. Let's take a look at the FSM for RDT 2.0. On the sending side, again, sender accepts data from the upper layer using RDT send, makes the packet for the data, and sends it using UDT send, and transitions to the state of waiting for the acknowledgement or negative acknowledgement. If a NACK, negative acknowledgement, is received, the sender sends the packet again and still stays in the waited state for ACK. This is repeated until there is a positive acknowledgement. If an acknowledgement is received and is positive, the sender does not do anything additional, which is depicted by the lambda in the transition actions, but transitions back to the waited state till it receives another packet from layer above. On the receiving side, RDT receive receives a packet from underlying channel. If the packet was corrupt, it sends an ACK and discards the packet. If the packet is not corrupt, it removes data from the packet and passes the data to the upper layer using deliver data. In both events, and after both actions, the receiver stays in the same state.